So I'm going to talk about my journey I did like 3 years ago when I got on the project, and kind of I wasn't very happy about it, so it looks like me was like already dead, not interested in. So myself and some guys, I have pretty good recreation with my work. I want to make it better. So essentially I want to tell you what was my journey to get not very interesting project more into more interesting, which is basically like functional oriented style, at least from my perspective. Why I'm going to talk today is just first of all, like, I called me, asked me if I wanted to talk, and I thought like probably not. And then later on I thought, okay, maybe I am going to share my journey as well with the business, how I had to, in a way, convince and battle them so I can do what is interesting for me and my team I'm working on. Because this is more like not only like pure programming, but it's also some sort of management and getting other guys to work with. So I'm going to share my experience. Maybe some of you are facing similar situations, so maybe you can somehow benefit from it. What it is not, so it's not the learning session about the functional programming, so this is a good huge topic, and probably every single detail could be worth of our meeting with you, right? So I'm assuming like we know something right now. And who is the audience? So if you guys are advanced functional programmer, sadly this talk is not for you. So if you guys are like little to medium experience, that you might have some benefits from my talk. Could I ask if how many advanced or experienced people in CAS perspective we have on this room? It's going to be easier for me to know how deep I should go with some things I'm going to touch. So essentially I'm asking who is advanced. Okay, some guys are. Okay, there is some guys are, some are not, so I have someone to too, so which is good, right? Otherwise I would pack my laptop, I guess, and let the next guy talk. Cool. So context, right? Like some time ago I got this half of the business logic to move, I got this task to move from legacy system to my payment code service, if you like, which I also consider like a legacy, so it's kind of standard thing we had in there, but anyway, we had to put in the code. We are moving from the old legacy system to our current one, which is also considered by me as the legacy, right? The journey like started with the business, so I was like, okay, get it as quick as cheap as possible. Of course, like business wants to have everything done like quick and easily and without that much cost, right? So that was the beginning. Then like I managed somehow convince. I'm lucky enough that my product team is kind of, some of those guys, they are pretty reasonable. So I managed to convince them we could take the opportunity since we are moving our logic, our services from one place to another one. Maybe we could kind of do some functional changes. They happily approve it, so there we go, we have a progress. So we are doing some refactorings, which means that we can change the code, right? Still, the same kind of all tech stack, play framework, same services, so everything like around is the same, nothing has changed, but at least like everything inside the services, the way we implement it, the way we design, like we have free hand for this, right? We can do whatever we want. In this case, myself and my team, we pick our favorite guys, so basically tech level, just most of the guys I think I'm working with is familiar with this one, as opposed to like, I don't know, Zio or some other frameworks. So that was this kind of a business context for my journey. Important part is that, I think this is the most important part, it was not an option that, okay, all service, we're going to downgrade and guys, you have 1 year to implement everything from scratch, and then 1 year later come back and give me a shiny new toy, right? So the whole journey is basically still working in the current whole system and keep improving over the time till we get to the point we want to do, right? So this is kind of a strategic approach to make, let's say, a Spring-like application for more like functional style. Okay, step first. So before I go there, so my talk is going to, my journey is going to be basically made of 4 steps. Step number 1, so the status quo, the current application. So let's imagine we, let me talk we as let's say, we are, let's say, for a sec, in the one team I'm trying to convince you to do something right. So we have like old applications bring like some like standard components that were like maybe they were functioning like 15 years ago, like some DAOs, statistics, controllers, whatnot, some connection to database, maybe some queues, in my case, Kafka cluster, and let's say you have some components, maybe less triggers, so it's not about taking REST request and saying the record database. You have some other components, maybe they are more intelligent than this, right? So let's assume we have very plain, not very complicated application, although it's not like, I don't know, it's online, right? It's like more complicated than this. So that would be starting point, at least in my case. Like, note I wanted to make this journey. I'm not too sure if I would be able to recommend if you guys have complicated system. I don't know, something like high frequency applications, maybe like highly concurrent. I guess like I said on the previous screen, probably like to do this kind of stuff in class or functional programming, you have to be already advanced developer in functional programming languages, right? So you know what to do in this case. Alright, so this is the first step. Let me show you right now the application, because I kind of like this slides with some application that can show you, like later on you can check out the GitHub and then see what I've done. So this is something that like showing that what I'm talking about, like it's like live TV. I just built very simple CRUD application which kind of exposes two endpoints. So one of them is a loading data. I have like one table, one entity called item, and then I added like another one to add item to collection, right? So first is database, 21, 22. So yes, it's kind of changing ID, so it's creating the new records. The first two calls, so this is like a insomnia collection, like a Postman style. First few endpoints, or let's say requests, we are hitting our legacy system. At the moment, I'm running like kind of our middle version, so something that is also exposing the newer version, so like newer API. So the second call I want to see, like the one that you can see here, like Vigo, is basically executing the same business logic, but it's not going really to say play framework, but it's going to something that is more functional, right? So the calls down there doing exactly the same thing, but I'm showing you that it's already working, right? Like some requests to show, I don't know, the request is invalid or some validation phase, so we have a response, okay? So this service behind the scenes, like everything seems to work. The project I have right now contains 4 commits, 4 branches, so each of those is basically one step from our journey. The first one is like, yes. So the first one is, like I said, nothing we are interested in. We are playing frameworks, some things called like a routes or routing table, something. Then there is a controller, like 2 endpoints or 2 functions, get data, add data, that's it. And I just come up with some, let's say, dummy service which does 2 things. One of them is loading data and the second is adding. Because later on we're going to go more toward functional side. Is the screen big enough, like you guys read it? No? Oh, you have a space, very nice, yeah, thank you, of course. Yes, so I just wanted to put like some logic in there, so it's not going to be like, okay, come to function and then we're going to make it functional, right? Makes no sense. So I just kind of come up with dummy logic. We have some sort of validation, some sort of processing. Processing actually makes like first letter uppercase, and then we are persisting, right? The last operation is storing the database. Validation is going to be like, I don't know, name to be long enough, flags that to show one of the parameters, and the most stupid way you could maybe implement validations is basically validation across all the possible combinations of the things you want to validate, right? I think the most stupid one would be if you're going to put the for comprehensions, because then you're going to block the first failure, so you're not going to present the whole problem back to, I don't know, end user. Cool, so this is the application, and we can move to the next step. Okay, so this is our starting point. The next one, So there is a few places we need to attack. So let's say we're gonna start from the back. And so yeah, as you guys know, like the controllers, like I said before, competing or repeat the tasks and high-level ecosystem. So the HTTP4S is going to be a web server or web framework which is going to replace Play framework. As you guys know, like not in Play framework and controls looks like what HTTP4S expects, so kind of it's not good much. Likely, like probably some of you, or maybe all of you know this tool or library called API made by guys from Software Mill. So essentially, this guy provides some sort of abstraction to define endpoints. And then the nice thing about this is like it allows you to integrate with the main web frameworks like I don't know, like HTTP, HTTP4S, and many others, right? So once you do the job on that tool, you define your abstract endpoints, then you can reuse it and like swap web servers as you like. And also this tool can be side by side with the existing native API that the web server provides. For our chart, like only 3 points are really important from this section. So the endpoint itself, like we can think about this as a function, it has input and outputs, so successful and failure as outputs, that's it. It's agnostic. Once we build it, it's like once and for all, right? Like even if we change the web server, we're gonna keep the code without any need for change. And also, like we need to have some sort of serialization. I believe, let's say if you're using Play, the JSON libraries using that probably could be used, but I would recommend if you are going over task and task effect, just use all the task stack from this ground, right? So the second point would be somehow define serialization for HTTP, I don't know, protocol and native request and JSON XML to say your model basic classes, right? And there is a small piece of code that is kind of hooking up our endpoints to the backend, which does the job, and also we need somehow integrate integrate the endpoints with the web server we are sitting on right now. So this is step 2. Let me show you how the thing would look like, right? So let me check out the step 2. So the text on my screen is very small and kind of blind. So in here, like we can see that we have like another entry. So this is the old Play framework, and we are like sticking a new abstraction to define our endpoint. So this is the Tapir logic or Tapir component here. So that's it. We are saying, okay, API version 1 goes to classic controllers. API, something else goes to our new endpoints defined here. So here is like a small component that Play framework requires. We need to implement straight or interface one of those, so kind of something given we have to do. So not so much code. And going from the top to the back end, the most interesting part. Then there is another piece of code we need to do to integrate with the Play framework. So essentially Play framework and web server, there's no idea about Tapir, so there's need to be a way to translate Tapir endpoints back to native web server, so this one can be used and understood, right? So this line of code essentially takes our abstract endpoints and basically convert it to something that Play framework and another web framework could digest. And moving on. So the next thing would be, you mentioned that there is a piece of code that we need somehow our endpoints, which I'm going to show you in a second, connect to our backend business logic, right? So like connect is one thing, but eventually this has to do some work. So this is very simple line of like one line of code, right? This is the endpoint that defines something. If the request ties to this, it's basically call this service and do this function. Simple as this. And the very last thing here I want to show on this step is how the endpoint looks like, right? So this is, like I said before, some sort of, you can think about this as a function. We start with the same function. It has one input and outputs. We have some other parameters like for authentication and a few other stuff, but let's say for this one, we can focus on inputs and outputs, right? So this is the whole thing, right? We define something like this and that's it. For inputs, we can put a few other stuff. Let's say this is a path, and eventually this is a definition of our request as the last step. So let me show you how it looks like. So the way we want to define the ultimate request object and the serialization would look like this. So essentially, like we are leveraging some JSON libraries to essentially convert JSON to base classes, right? So this is all we need. And once we do it, we can take it and travel across different web frameworks, web servers as we please. So I think this is pretty nice, doing something once and for all, and being kind of independent from a web server we are sitting on, right? So that was a step 2. What is next? So if we are going to get this thing done, what was the next stop on my journey? So the fun part, right? So here are a few things like, in my case, what we've done, we've applied in a way, Douglas Finer-ish pattern, if you like, to make our code like one more step toward functional programming. I will get to this a little bit more in detail. Why it's like ish, not exactly. And here are a few points to say at this phase. So one of them, like if you were coding, maybe more like directly functional programming should not be much work. But if you were, let's say, last year you were Java developer, you started Scala Developer, it's likely your code is more interactive than functional. So probably like a lot of your business logic you have to be like rewritten from scratch, right? To be more like monadic way. So this is one of the things to know when you guys will be like planning how much work it's going to take. The second thing in my case was that you may encounter some pieces of code which will be difficult to implement in halfway functional style. So for example, like at this point we are going to apply class or classic and not the IO, so this is something like halfway through. And then you may like be using some, I don't know, libraries, for example, database connection, some legacy code that cannot work with IO. So this is something we have to do with cast, and even with cast it would be impossible or very difficult to implement. So if this is the case, you're gonna have then, okay, leave it for now, okay? If there is, let's say, some old Java way of coding database, and this is something that cannot easily be integrated or nicely integrated with cast, leave it for now, we're not gonna touch it, okay? And the second thing that in my case was, okay, you may have some other less trivial pieces of business logic, and it would be maybe difficult to implement in cast only. So what we've done, is essentially, okay, if you can move it, extract from a service and move it to another microservice, so do it, right? So I mentioned before that we have some components, some sort of scheduler or scheduler, depending on the language used. So in this case, it would be maybe kind of overcomplicated using cast to implement what you wanted without having all the tools from cast effects. So basically, we took it from the small payment service and moved it to small microservice on site and implemented everything from scratch on the high-level ecosystem, right? So this is a thing to do. As small disclaimer, like in my real commercial work, I got this far, a little bit more, and then I was asked to move to other, like another project, and also, like I said, there was half of the logic move, so there's another half to be updated. So the step number 4, this is something that is ongoing right now in a way, but it's not fully done, so I wanted to be transparent with you guys that I'm not going to say that that's something while it's not fully complete. One more thing, so this is kind of for the guys who are starting with functional programming, so we're going to look at both. But let's say if you're going to have this first yellowish box, so this would be your service, right? My service will do something, the one I showed at the beginning. And then the way I've approached this, okay, so let's kind of convert it more like something is going to be easier for the next step to work with the task effect. So we're going to update for all our services components, whatever we have, or define for them interfaces, let's call them Jira, right? So this is some sort of ESL where you define the number of operations or actions you want to run. So the only thing is that we need to make sure that our interface is going to be kind of, I don't know, have some sort of context or effect like F, as opposed to like specific one, future or something else, right? This is important. So if you're gonna have this interface, then the next thing is like the abstract class, the guy in the middle. So this is the part at this stage, we wanted as much from the ASCII code implement in the class, as much as we could, right? Like everything that is doable, let's put it there, right? So this my service interpreter, so actually implementation of that would be here, right? And the last bit at the bottom would be my service, so essentially all the ASCII code. So if there is something that for the database you are using, like before frameworks or components which cannot talk to us or anything like this, just leave it for now, right? So this is it. The picture drawn by Sally. I don't have this nice funny pictures. It's basically on how to draw the picture on the right-hand side to sum up where we are at the moment. So let's say this B square is our whole service or application implemented in a functional way. Then we have some components like maybe Kafka integration database, maybe REST clients. They still work in the same way it used to be before. This is here at the bottom, so let's say this is the piece of code that we managed to take it out from our service and move it to microservice. So problem solved. There is one more thing that I haven't covered because I think that would be too much for this presentation. I just put small and box in the greenish shape. So I just wanted to say that I've done the proof of concept, but can go to production eventually. That even if you have like an ASCII application based on Play, there is a way you can take part of this business logic and implement in I/O, right? So I/O, for example, provides some helper functions where you can convert future back to I/O, and from future you can also I/O and future you can convert as you please. So there is a way you have complicated code, and then you want to build it like right away in I/O because it will be much easier than you could do it, right? There are some challenges, like for example, one of them had a problem with logging, so essentially like the log aggregator, like trace ID got lost, so the context and then the thread code that was handling, let's say some sort of span ID or trace ID got lost, but anyway, it's doable, right? So there is also one more thing to add the thing that seems to be maybe too complicated or not worth implementing fast. Cool. So that would be a step 3 at this point. We have, I don't know, bigger part of our application implemented in functional kind of way, although it's not 100% transparent yet, right? But you are basically looking like one. And so let me show you right now what that would be the goal. Actually, I can show you on this picture one that we can quickly look at this. So that would be, there you go, right? So before there was, I can't remember like what the original implementation for text interface, but the one that I discussed on the slide, we have a trait, which is like algebra, like all the middle guy. So this is the old ASCII code compared to the new one. So as you can see, nothing really has changed really at this point, like the validations on dummy processing persisting. For those guys who are completely very new to the functional programming, right? So if you remember before, we were having this some sort of all permutations against pattern matching. Now, once we start deploying tasks, we have an option to kind of leverage and use all the concepts like in this specific case, it's like applicative rights that are supposed to honor. So it's very good for validation. So we're going to dump everything in there as the input arguments, and it's going to validate all of them, and then we're going to collect it again, all the errors that would happen. So pretty much looks like the other guy. Before in the first version, we have, let's say, validation flag, validation name. We were returning like either. Now we are returning like something else, right? Like the validator. And I know that this is kind of the same thing, but more rich and more embedded in functional, I don't know, like theory, right? That kind of provides you, allows you to use theory behind the applicatives, for example. So that is great, but it's kind of less code, more than not zero to manage. One more thing I want to say, we'll forget later on, for the guys who are like kind of new, if, wait, this is, yeah, there is this one idea, right? So like often when we do the job, because essentially our job is kind of keeping some sort of context. We know at the back of our head that we're gonna go to I/O, but right now we are still dealing with the future. But yeah, even if we have futures, we wanna think about them as the I/Os, which we're gonna move in the next section. And then like for guys who don't wanna like I don't know bother too much, the monadero is something in my case kind of was pretty rich. Implicit object provides you quite a rich API. I think it contains like everything from like monads, applicatives, and all the other components like functors and whatnot. So essentially, like in my case, like having this guy included kind of allows me to use pretty much most of the functions from Cask, right? Cask classic, if you like. I know it's against maybe TA, we should use the implicits like the least powerful, but I don't know. For guys who are starting, probably that would be easy and good enough to pick up. So monadero is the guy that kind of allows us to use functions like I don't know, pure, map, flat map, all the stuff you are kind of used to use. And nothing else, you don't have to bother, okay, so like the same casting in case of casting. Cool. So that would be a step number 2. And now I'm going to go to the next one, and this is the last one. And the next step would be, onboarding the HTTP4S, right? So, default framework for web-level ecosystem. So, probably everyone should pick up if you stick with that task. Then basically very few actions we have to do. And first of all, get rid of play framework, so everything that was in web or web folder, just like get rid of this. Actually, most of the stuff moved to another folder, which is source Java main web. Is in this place, instead of put the HTTP4S and kind of start using IOs, and then that's it, right? Like the IOs taking over features job. And you are free to use entire type level ecosystem. So let me show you when it's done with my time. So master is actually step 4. So actually I am going to show you like it's slightly different, right? If I do the diff between I forgot to remove some. This whole project basically I just use the templates and bootstrap everything from scratch for the display framework and then Sleek for databases, and then I move to S2 and Loop, right? So like this code in here is basically I use the default templates, so I forgot to remove this apologies. So some folders should be there. I wanted to see the difference. It says move, right? So I move. If I'm going to show you the diff, right? So as you can see before, there was nothing about IOs, and the middle guy is the same, right? Like, without having any IOs, I just didn't touch any code in there, right? It's the same. And now we are fully IOs. Right now we are seeking proper HTTP4S web framework. So this is the thing we wanted to achieve in step number 4, having most of our code ready for IO. The only thing that will change, something that before was, let's say, database operations, and they were against futures and Sleek. Now we have moved them over. Moved them in this project to our main implementation because our data subject based on futures now is part of type level ecosystem, right? So right now we have these components which I said, okay, it would be difficult to implement tasks. Now we can use them. We can use them as our main implementation. So there is this algebra interpreter, and that's it, right? At the end, at the bottom, we have just like function that defines the service, right? So like instantiated. Just wanted to show that we are. Right? So this is like the main application where I'm scrapping all the components, and we are kind of creating our service, which was part of play framework and futures and all those non-lazy stuff. Now this is like fully sitting on top of the IO, right? So done at this point we can use anything we want without much issue from regular ecosystem, right? Let me see if I have anything else to show. For the guys who are, let's say, maybe like some of you here, like if you were reading about us, functional programming, and you know how to do like the local scale, like some exercises, and you were wondering, okay, how could I apply this for the whole enterprise application? So that was my job. But my advice is keep it simple, right? And don't. The simpler you keep it, I think is going to be better, at least at the beginning of the journey, especially I could give you a warning like, don't keep, let's say, don't play too much with the monad transformers, so like you're gonna have monad nested monads, because it looks nice, okay, you're gonna have IO of I there, but at some point you're gonna use more complicated, useful, I don't know, I don't know, state monad, like I was using. So then you're gonna have state monad with like IO with something inside the, which is either, for example, right? So like if you're gonna, maybe some of you are gonna decide to check out the project, you're gonna have a look. I kept everything as an F, right? So there was a failure was F, exception, and if there was success, there was the value I wanted to have it. So having not much nested monads would basically kind of save me like a lot of headache in the future, right? Okay, so we are done, and time is up, and basically I had the last page say thank you, and into a GitHub project. That's it.